Good evening, everyone. Welcome to week 11 problem solving session. Today I'll be discussing questions related to week 11 lecture materials and assignment solutions. So let's start. The first question is F2 treatment with H2O at 298 degrees Celsius. Give option A is HOF and F2. Option B is HF and F2. Option C is HF and O2. And option D is HOF and O2. So it should be in Kelvin. F2 reacting with water at 298 Kelvin will give HF plus HOF, but this HOF will directly immediately undergo dissociation. So to HOF at 298 Kelvin, it will undergo dissociation to give 2HF and O2. So the final product will be HF and O2. So the answer is option C. Next question is S8 react with AsF5 in presence of liquid O2 to give option A AsF3, option B S8 AsF6 twice and AsF3, option C is S AsF6 two times and AsF3, and option D is S AsF3. So sulfur has catenation property, and reacting with AsF5 will form a cationic complex of sulfur. So the reaction is S8 plus 3AsF5 in liquid oxygen. It will give S8 2 plus AsF6, which is in negative oxidation state, and 2 times plus AsF3. So the answer is option B, S8 AsF6 twice and AsF3. And similar properties present for tellurium as well, because tellurium can form cations. So 6Te in oleum will give Te6 4 plus. The next question is the shape of SOCl2 and SO2Cl2 respectively are option A trigonal bipyramidal and square planar, option B trigonal pyramidal and tetrahedral, option C trigonal planar and tetrahedral, and option D is trigonal bipyramidal and square planar. So sulfur has 6 electrons in its valence shell. So sulfur will be having 6 electron pairs, and in SOCl2 S double bond O Cl and 1 lone pair will be present, and in SOCl2 SO2Cl2 it will be S double bond O Cl and Cl. So all the electron pairs are bond pairs in SOCl2. SO2Cl2, and there is one lone pair present for in SO2Cl2, one lone pair will be present, and in SO2Cl2, there is no lone pair, only bond pairs are present. So, steric number is 6 plus uh, so steric number will be number of total number of bond pairs and non pairs. So 3 plus 1 equal to 4, and in 4 one lone pair is present if steric number is 4, geometry is tetrahedral, but one lone pair and 3 bond pair, that means the structure will be trigonal pyramidal. And here also steric number is 4, geometry will be tetrahedral, and all are bond pairs, so 4 bond pair, so it's tetrahedral shape. So SOCl2 is trigonal pyramidal and SO2Cl2 is tetrahedral. So option B is the answer. And the synthesis method for SOCl2 and SOCl2 are for SOCl2, SO3 reacting with SCl2 will give SOCl2 plus SO2, and SO2 with PCl5 will give SOCl2 and POCl3. And SO2Cl2 is synthesized by SO2 reacting with Cl2 on activated charcoal. So SO2 plus Cl2 on activated charcoal will give SO2Cl2. Next question is, the correct statement on disulfurous acid is option A, both the S atoms have oxidation state +3. Option B, both the S atoms have oxidation state +5. Option C, there is one SS bond in molecule. And option D, it is monoacid. So we are asked for disulfurous acid. So the structure for disulfurous acid is molecular formula is H2O5, and the structure is S double bond O OH double bond O S double bond O OH. This is the structure for disulfurous acid H2S2O5, and so in the statements both S atoms have oxidation state plus 3. So we should calculate the oxidation states. So we don't calculate the SS bond, so we can separately calculate the oxidation state for both sulfurs. So on oxygen it's 2 minus, and on hydrogen is plus 1. So 2 plus 2 is 4, plus minus 2 is minus 6. So minus 6 plus minus 1 is minus 5. So minus 5 is the total negative charge on the sulfur. So to neutralize this, sulfur should have plus 5. So this sulfur is plus 5 oxidation state. And here again oxygen is 2 minus and hydrogen is plus 1. So 2 minus plus 2 minus is minus 4, and plus 1 is minus 3. So sulfur should be having positive 3 to make it neutral. So the charge on this sulfur will be plus 3. So in H2SO5 disulfurous acid, two different oxidation states are present. For the sulfur with 3 oxygen directly coordinate to sulfur, it has plus 5, and the sulfur with one double bond O and one OH, it has plus 3 oxidation state. So the statement 1 is wrong because it says both the S atoms. So it is wrong. Only one S atom is plus 3, and again the option B is also wrong because it said both the S atoms, but only one sulfur is plus 5. And third one is there is one SS bond in molecule. So this statement is true because there is one SS bonding present in disulfurous acid. And fourth option is it's mono acid. So we can see that there is two OH bonded to sulfur directly. So we can remove both hydrogen as H plus. So monobasic acid is only one OH. That means only one H plus can be removed. And dibasic acid, two OH groups. Two H plus can be removed. So here two OH is present, so two H plus can be removed from disulfurous acid. So the statement is wrong. Disulfurous acid is dibasic acid. So the answer is option C. There is one SS bond in molecule. Next question is CaF2 on treatment with H2SO4 gives. Option A is F2 plus CaSO4 twice plus SO2. Option B is HF plus CaSO4 twice. Option C is HF plus CaSO4 twice. Option D is F2 plus CHSO4 twice plus SO3. So the reaction of CF2, there is two set of reactions present. So first one is CaF2 with two molecules of H2SO4. it will give 2HF plus CaHSO4 twice. And if there is only one H2SO4, CaF2 plus H2SO4 will give CaSO4 plus 2H. So in the options, we can see that CaHSO4 twice and HF is found. So option B is answer. Here CaSO4 and 2HF is present on the second reaction. So in the given option, there is no CaSO4, only CaSO4 twice is given. So we can see that the second option will be the answer since they have not given the second reaction. So the answer is option B, HF plus CaHSO4 twice. So HBr can react with H2SO4. So 2HBr plus H2SO4, it will liberate Br2 and SO2. So next question is the option depicting correct statements about hydrogen halide is. First statement is stability of hydrogen halide decreased down the group due to increase in the mismatch of atomic orbital with hydrogen. Second one is Hi in equilibrium is H plus and I3 minus. Third one is accept hydrogen fluoride, boiling point and melting increases down the group. So let's go through each statement. First one is stability of hydrogen halide decrease down the group due to increase in mismatch of atomic orbital with hydrogen. So the statement is correct. So down the group, the size of the orbital increases, and also the electronegativity also decreases down the group. So the orbital mismatch will be higher from moving from top to bottom. So the elements of fluorine, chlorine, bromine, and iodine. So while moving down, electronegativity decrease. So the atomic orbital energies will be different, and it will be higher than orbital energy of hydrogen. So the there will be orbital mismatch, and the bonding will be weaker. So the stability of hydrogen halide decrease down the group. Second one is Hi in equilibrium is H plus and I3 minus. So the statement is wrong because Hi will be in equilibrium with H2 and I2. So 2Hi be H2 plus I2. And third one is accept hydrogen fluoride, boiling point and melting increases down the group. So the statement is true because in hydrogen fluoride there will be presence of hydrogen bonding, so it will be having highest boiling point and melting point, and while moving down the group the BP and MP increases. So the correct option is option C. Statement 1 and 3 is correct. Next question is uranium on heating with ClF3 give. Option A is UCl6 plus ClF. Option B UF6 plus ClF. Option C is UF6 plus Cl2. And option D is UCl6 plus F2. So ClF3 can act as a fluorinating agent. So reaction of uranium plus 3ClF3 will give UF6 plus 3ClF. And ClF3 can react with ASF5, ClF3 plus ASF5 will give ClF2 plus and minus F6 minus. So the correct answer is option B, UF6 and ClF is produced when uranium is heated with ClF3. Next question is 1:1 reaction between XeX6 and H2O gives. Option A is XeOFO, option B is XeO3, option C is XeOF2, and option D is XeO6 4 minus. So the reaction is XeF6 plus H2O. So this is a reaction to produce XeOF4. So it will give COF4 and HF. Other reactions to synthesize XeOFO are XeF6 plus NaNO3 give XeOF4 plus NaF plus FNO, and XeF6 plus POF3 giving XeOF4 plus PF5. So this is one of the oxyfluorides of xenon. We can synthesize XeO3. So here oxidation state is plus 6. Here also it's plus 6. So XeO3 is synthesized from XeF4 and XeF6. So 6 XeF4 plus 12 H2O will give 4 Xe plus 2 XeO3 plus 24 HF plus 3 O2, and from XeF6 reacting with the water, it will give XeO3 plus 6 HF, and XeO6 can be obtained from XeO3. So here it will be plus 12. XeO3 plus OH minus will give xenate anion, which is XeO3 OH minus, which is xenate and this anion react with OH in aqueous solution to form HeO6. And a controlled oxidation reaction of HeX6 will give XeOF2. So here the question was 1:1 reaction between XeF6 and H2O gives. That's our first reaction. So it gives XeO, F4 and HF. So the answer is option A, XeO, F4. And if there is 1:3 ratio, then it will form XeO3. Next question is metal present in dehydrogenase enzyme is option A cadmium, option B is iron, option C is mercury, and option D is zinc. So in most of the enzymes, zinc is present. So here there is three examples of enzyme is given. First one is carbonic anhydrase, second one is liver alcohol dehydrogenase, and third one carboxypeptidase. So in the enzymes, zinc will be the central metal and it will be coordinated to different peptide chains. So three uh, coordination will be satisfied with uh, the groups the amino acid groups of peptides, and the fourth one will be coordinated to water and OH. So we can see that the fourth coordination in oil is satisfied with water. So it will be replaced with whatever molecule we have to change. So the major role of enzyme is to uh, change whatever the other molecules present in our system. So in carbonic anhydrase, it will remove CO2 from blood and it will maintain the pH of blood. So the reaction will be H2O plus CO2 and it will be converted to H plus and HCO3. So this reaction will be controlled with the carbonic anhydrase, and in liver alcohol dehydrogenase it will act on the alcohol and it will uh, dehydrate the alcohol and it will degrade the alcohol and absorb in the body. And third one is carboxypeptidase, where it will be used to break peptide bond in proteins. So these are the three small enzymes present in our body. So we are asked the metal present in dehydrogenase enzyme. So in dehydrogenase enzyme, zinc is the uh, metal present. So option D is the answer. Next question is in XEF ASF6 The number of bridging and terminal fluorine atoms present is option A is 3 and 4, option B is 2 and 7, option C is 1 and 6, and option D is 0 and 6. So the structure is uh, so the structure of XCF plus and SF6 minus is this one. So we are asked to find number of bridging and the number of terminal fluorine. So only uh, one bridging is present, and terminal fluorine are 1, 2, 3, 4, 5 and 6. So 1 bridging and 6 terminal fluorine are present. So option C is the answer, and the synthesis route is XeF2 plus ASF5. So both are in 1:1 ratio. Next question is sulfur dioxide react with PCl5 to give. Option A is S2Cl2 and PO2Cl2. Option B is SO2Cl2 and PO2Cl2. Option C is SOCl2 and POCl3. And option D is SCl2 and POCl3. So the reaction is SO2 plus PCl5. So it will give SOCl2 and POCl3. Two of the chlorine will be given to sulfur and one oxygen will be taken by phosphorus. So SOCl2 and POCl3 will be the product. So option C is the answer. Next question is solid state structure of TeF4 and TeCl4 respectively are. Option A is polymeric and dimeric. Option B is polymeric and tetrameric. Option C is dimeric and tetrameric. And option D is trimeric and polymetric and polymetric, trimetric and polymetric. So TeF4 is polymeric and TeCl4 is tetrameric. So other examples for tetrameric are SeCl4, SeBr4, TeBr4 and TaCl4. The structure for TeCl4 is so Te is present on the alternate corners. So and Cl is 1. Okay. So Te is present on alternate corners, and Cl4 is present on the remaining corners of the cube. So first, for if we consider this uh, tellurium, so the adjacent corners are occupied with chlorine. So if we extend this edge towards the left side, so next chlorine will be present here, and other will be here. And if we extend this edge into the back side, so next chlorine will be present here. And if we extend this edge to the top, this will be the adjacent chlorine. So if we consider this particular tellurium, this will be the first chlorine, second one, third one, and fourth one for this first tellurium. And for this one, we can consider this as the second tellurium. This one is the second tellurium. So this one is the chlorine on the second one, and this as well. So all this dark blue will be the chlorine on tellurium. So if we give this one as the third tellurium, this will be the chlorine one. And if we give this one as the fourth one, so this will be the chlorine on fourth. So if we count, there is 4 chlorine on each tellurium, and it's tetrameric since there are 4 such units present. So TeCl4 is tetrameric, and TeF4 is polymeric, and the structure is given like this. So the answer is option B. TeF4 is polymeric and TeCl4 is tetrameric. Next question is products produced on heating K2MnF6 with SPF5 at 420 Kelvin are. Option A is K, SPF6, K3MnF6 and F2. Option B is K, SPF6, K2MnF5 and F2. Option C is K, SPF6, MnF2 and F2. Option D is K, SPF6, MnF3 and F2. So the reaction is K2MnF6 plus 2SbF5 will give 420 Kelvin will give 2 KSbF6 plus MnF2 plus. So the answer is option C, KSbF6, MnF2 and F2. Next question is the oxidation number of sulfur in dithionate S2O4 2 minus and dithionate S2O6 2 minus respectively are. Option A is +3 and +4. Option B is +3 and +5. Option C is +4 and +5. And option D is +4 and +6. So dithionate means two sulfur groups will be present in with SS bond. So in S2O4 2 minus SS double one O minus double one O. So to calculate the oxidation state, we don't need to consider this SS bond. So we can draw a line like this and calculate oxidation state in both sides, but both are both will be having same oxidation state because both are having similar bond types. So both are connected to two oxygens. So here it's 2 minus for one oxygen and it's already given negative for other oxygen. So total will be -3. So this oxygen state will be +3 and here also it will be +3. So in S2O4 oxidation state is +3 and in S2O6 2 minus the structure is SS O minus double one O and double one O minus. So similar to this again here also we don't need to consider S bonding and both sulfur has same environment, both are connected to 3 oxygen. So for this 2 minus and minus is given, so total will be -5. So the charge on the sulfur should be +5. So here also it will be +5. So oxidation state of sulfur on S2O6 2 minus will be +5. So the answer is option B, +3 and +5. So S2O4 2 minus is prepared by reaction of SO3 2 minus with water. So 2 SO3 2 minus plus 2H2 plus 2 electron, it will give 4 OH minus plus S2O4 2 minus. Here reaction of MnO2 with SO3 2 minus. The next question is the hybridization of tellurium in TeCl4 is option A is sp3, option B is sp3d, option C is sp3d2, and option D is dsp2. Tellurium is in the group of oxygen, so the valence electron is 6. So ns2 np4 configuration. In tellurium it will be 5s2 5p4 configuration, but in TeCl4 tellurium is in +4 state, so 5s2 5p0. And the TeCl4 T6 valence electrons, so Cl4 4 chlorine connected to tellurium. So steric number is 6 plus 4 by 2, which is 5. 4 bond pairs and 1 lone pair. So steric number 5 means 5 uh, hybrid orbitals required. It is 4 bond pairs and 1 lone pair. So we have 5s 5p and 5d orbitals, and for 5 hybrid orbitals we need 1 5s, 3 5p and 1 5d orbital. So 5s 5p and 1 orbital of 5d will be hybridized to give 5 sp3d hybrid orbitals. So the lone pair will be occupied in 5s, and the 4 bond pairs of TeCl4 will be present in rest of the 4 orbitals. So the answer is option B, sp3d hybridization for TeCl4. Next question is the set with correct order of acidity is option A HClO4 greater than HClO3 greater than HClO2 greater than HOCl. Option B is HClO4 less than HClO3 less than HClO2 less than HOCl. Option C is HClO3 greater than HClO4 greater than HClO2 greater than HOCl. And option D is HClO3 less than HClO4 less than HClO2 less than HOCl. So for a given element in halogen, the strength of oxyacid increases with oxidation state of the halide. So from the dissociation constant, we can see that as the number of oxygen increases in the oxyacid, the acid dissociation constant increases. So for HOCl, it's 2.8 into 10 to the power minus 8. And when it goes down to HClO4, it becomes 10 to the power positive 7. So it's a very high difference between these dissociation constants from minus 8 to plus 7. It's almost 10 to the power 15 difference. So it means that uh, HClO4 is highly acidic compared to HOCl because the oxidation state of Cl is higher in HClO4 compared to HOCl. So here oxidation state of Cl is plus 1. Here it will be plus 3. This will be plus 5 and here it's plus 7. So the acidity order increases down the group. So option A is the correct answer. HClO4 greater than HClO3 greater than HClO2 greater than HOCl. So we can draw the structure of each acid as well. In HOCl, the structure is HOCl. So Cl is plus 1 oxidation state because oxygen is in -2 and H is in +1. And next one is Cl HClO2. The structure will be ClOH and the bond O and 2 lone pairs will be present, and oxygen state will be plus 3 because this one is -2, -2 and +1. And next one is HClO3. Structure is ClOH and double O and 1 lone pair. Here oxygen state is plus 5 because -2, -2, -2 and +1. And next one is HClO4. Cl double O OH. So -2, -2, -2 and -2 and +1. So total will be -7. So oxygen state of Cl is +7. Next question is XCF2 on treatment with ASF5 in 1:1 ratio gives. Option A is XC2F3 ASF6. Option B is ASF4 XCF3. Option C is XCF ASF6 and option D is ASF4 XC2F5. So XCF2 with ASF5 in 1:1 ratio will give XCF6 XCF ASF6 because XCF2 is a fluorinating agent. So the answer is option C, HCFASF6. So other reactions of HCF2 are reacting with the Me3AS will give Me3ASF2 plus Hc. So here the HCF2 can act as a fluorinating agent as well as oxidizing agent because the central atom oxidized state will be increased. And HCF2 is a linear molecule because Hc will be having 8 electrons in its valence shell. So in HCF2, 2 fluorine connected to Hc. So steric number will be 3 plus 2, that is 5. So when there is steric number is 5, the geometry will be PBP, trigonal bipyramidal, but there is only 2 uh, bonding uh, bond pairs are present and 3 are lone pairs. So in TVP, what happens is that lone pairs will be placed on the equatorial plane to minimize the repulsion. So Xc will be linear, XCF2 will be linear, and 3 of the lone pair will be placed in the equatorial plane. Other fluorides of XCF4 and XCF6. So XCF4 and XCF6. So their structures are in XCF4, it will be square planar because in XCF4 the structure is square planar because steric number is 6, but 2 lone pair and 4 bond pairs are present. So if only 6 bond pairs are present, it will be octahedral. But here 2 lone pairs are also present. So 2 of the um, lone pairs will be placed on axial positions. So structure will be square planar. In XCF6, structure will be octahedral. And the lone pair will be placed in between 2 fluorine. Next question is the shape and point group of ClF3 molecule is option A is V-shaped and C2V, option B is seesaw shaped and C2H, option C is T-shaped and C2V, and option D is T-shaped and C2H. So in ClF3, chlorine has 7 valence electrons and it's bonded to 3 fluorine. So 1, 2 and 3. So 3 bond pairs and 2 lone pairs are present. So the steric number is 5, and steric number 5 means geometry is trigonal bipyramidal, but the shape is T shape because two of the lone pair will be placed on the equatorial plane. So the structure will be so two lone pairs on the equatorial plane and one fluorine on equatorial and two fluorine on axial. So this is the T shape. If we rewrite F, F and F. So this is the T shape. In here, we are asked to find the point group as well. So for T shape, the point group will be C2V because it has a C2 axis along this CLF bond. So if we rotate in 180 degree, this fluorine moves to here and this move to here. So the original shape will be remained. It will not change when we apply a 180 degree rotation along this CLF bond. So one C2 axis is present here, and we can cut, we can place a mirror between this FCLF bond. So passing through this CLF bond. So if we place a mirror here, this CLF bond will be reflected and giving the same configuration. So there is one mirror can be placed between this CLF bond. So one sigma, that sigma means uh, a mirror plane passing through, sigma v means mirror plane passing through C2 axis, and we can again place another plane uh, along this screen. So it will lie between, uh, if we place a mirror slicing through middle of this molecule, so it will reflect uh, all the elements, so it will not change its positions. So again there will be two mirror planes present, so two sigma v is present and one identity element, which is if we don't change anything, the molecule as it is, that's the identity. So there is four elements present for this molecule. So C2 and 2 sigma V means it's a C2V molecule. So the answer is option C, T-shaped and C2V. You will learn more on the point groups in the group theory subject. So if you don't understand, just know that molecule with a T shape, which has all the atoms are same, it will have C2V. Other example for C2V is H2O, and there is C3V, which is NH3. So in ammonia, what happens is that here we have a C2 axis, which can be rotated in 180 degree. So this H will interchange. Here there is Where? I don't think so. No, I think he went home. Yeah. I think everyone left. Uh, I'm actually having class right now. So in NH3, what happens is that there is three hydrogen groups. So if we rotate here uh, in 120 degree, it will be if I rotate uh, this molecule with the axis passing through the center of nitrogen in 120 degree, this hydrogens will get interchanged. So this hydrogen will move position to this hydrogen, this will move to this, and this hydrogen will move to this side. So if I rotate in 120 degree, the movement of hydrogen will take place, but the hydrogen will remain, will have another hydrogen, so the structure will not change. So this structure is C3V. So you will learn all about the point groups and the elements of the molecules in group theory. Next one question is hydrolysis of I2O5 gives. Option is HiO2. Option B is HiO4. Option C is HiO3. And option D is HiO2 and 2 HiO3. So the answer is I2O5 plus H2O giving 2HiO3. So the answer is option C. Hydrolysis of I2O5 will give HiO3. Next question is the reaction of xenon hexafluoride XeF6 with NaNO3 will give. Option A is XeO3, NaF, NO2 and F2. Option B is XeO4, NaF and FnO2. Option C is XeO2, F2, NaF and FnO2. Option D is XeO3, F2 and NaF and NO2 and F2. So the reaction is XeF6 plus NaNO3. So it will give XeOF4 plus NaF plus FnO2. So other reaction of XeF6 are XeF6 react with water to give XeO3. XeF6 plus water in 1:1 ratio will give XeOF4 1:3 and 1:1. So the product will be different on the number of uh, water or the ratio of XeF6 and H2O we are taking. So 1:3 will give XeO3 and 1:1 will give XeOF4. So next one is XeF6 reacting with POF3 will give XeOF4 plus PF5 and Another reaction is HCF6 plus 2BOTEF5. 3 times will give HCOTEF5. 6 times plus 2BF. So the answer is option C. Reaction of xenon hexafluoride HCF6 with NaNO3 will give XeO2F2. So the answer is option B. Answer is option B. XeOFO, NaFN, FnO2. The next question is write down the oxide formation reaction in halogens. Fluorine 2F2 react with OH minus, giving OF2 plus 2F minus plus H2O. So in OF2, F is in negative charge because fluorine is the highest electronegative element present in periodic table. And next one is Cl reacting with HgO. I2 react with oxygen to give I2O5. React on oxidation with ozone at 195 Kelvin will give B2O3, which is orange in color. And further oxidation with ozone at 195 Kelvin will give B2O5, which is colorless. And Cl2 can react with sodium carbonate in water. It will form Cl2O. And KClO3 reacting with KClO3 reacting with oxalic acid H2C2O4 will give K2C2O4 plus 2ClO2 plus 2 water molecule. Then 2 NaClO3 reacting with SO2 and H2SO4. It will give 2 NaHSO4 plus 2 ClO2. And the reaction is ClO2F plus HClO4 will give Cl2O6 plus H. So that's all for today. If you have any doubt, you can ask. Thank you.